All right, you are welcome again. Today, let's talk about a very important topic. I want us to see everything we need to know about equation of tangent and normal. Equation of tangent and normal. Now, let's take a look at this question. Find the equation of the tangent and normal to the following curves. Number one, we say y is equal to 1 minus x in bracket 2 plus x in bracket at the point where x is equal to 2. And then number 2, y is equal to 1 all over 2 x squared plus 1 at x equal to minus 2. And then number 3, y is equal to 3x cubed at x equal to 1. We are asked to find the equation of the tangent and normal to the following curves. Okay, now take a look at this. I want to list few things that we are required and what we are going to do. The first thing, we are going to look for the point of tangent. For us to find the equation of tangent and normal, the first thing we are going to look for is the point of tangent. Secondly, we are going to look for the gradient of the tangent. We are going to look for the gradient of the tangent. And then the third thing, we are going to look for the equation of the tangent. So, when we get the point, get the gradient, we'll be able to find the equation of the tangent. And when we find the equation of the tangent, we also find the gradient of the equation of the tangent that is perpendicular to it. Hello. We find the gradient that is perpendicular to the equation of the tangent. And then that gradient that is perpendicular to the equation of the tangent will help us to find the equation of the normal. Please, in this video, I'm going to split it step by step, where it will be very easy for you to understand and solve any kind of question on equation of tangent and normal. Okay, now we see a question. We have 3 questions here, right, to treat. Now the first one say y is equal to 1 minus x in bracket 2 plus x in bracket at a point where x is equal to 2. The first thing we are going to do for us to find the equation of tangent and normal to this curve, the first thing we are going to do is to find the point. You know that point is always given as p over bracket x comma y. Is that true? Yes. Now we are going to find the what? The point. Now take a look at the curve. We have y is equal to 1 minus x in bracket 2 plus x in bracket. Let's open this bracket. When we open this bracket, that means it's going to say 1 times 2 is going to give us 2. 1 times x in the next bracket is going to give us x, minus x in the first bracket times 2 in the next bracket is going to give us minus 2x, and minus x in the first multiplied by x in the next is going to give us minus x squared. So this is giving us 2 plus x minus 2x minus x squared. So when we say x minus 2x is going to give us minus x. So here we have 2 minus x minus x squared. But you know that point is always written as p of x comma y. And then we know the point, what? X to be what? 2. And then for us to find y, what are we going to do? Now we say that y is equal to 2 minus x squared. Can you see this? We say that y is equal to 2 minus x squared, and then x is equal to 2. So in this place, let's replace x with 2 to find the value of y. That will give us the point p of x comma y. Now if we fix it in, we are going to say that the function here, now we have y is equal to 2 minus x squared, right? So when we fix in 2 here, we're going to say that y is equal to 2 minus open bracket 2 close bracket minus 2 squared. So when you see this, we're going to see that we have 2 squared is 4. So here we have 2 minus 2 minus 4. So 2 minus 2 is equal to what? 0. And then here we have minus 4. So we have that y is equal to minus 4. Now we have succeeded in getting the point. So at x equal to 2, then our y is minus 4. Then we say the point P, open bracket 2, comma minus 4. All right. Now let's go further to find the gradient of the tangent. The gradient of the tangent. Now, we have our y is equal to 2 minus x squared. So for us to find the gradient, we are going to differentiate this function. So when we say the f prime of x or y prime, which is the derivative form of y. So let's differentiate the function. So we're going to have minus 1 minus 2x. So when you differentiate 2, it's going to give us 0 because it is constant. And when you differentiate minus x, it's going to give us minus 1. When we differentiate minus x squared, it's going to give you minus 2x. So y prime is equal to minus 1 minus 2x. So for us to find the gradient, we're going to plug in x in this place. So gradient is talking about the f prime of x of the function you have. So the f prime of x is what? The gradient. So we have differentiated, we have f prime of x. So and then we say that x is equal to 2. That means we are going to say f prime of 2. So f prime of 2 is going to see that anywhere we have x in this differentiated function, we replace it with 2. Okay, so here we're going to have f prime of 2 is equal to minus 1 minus 2 open bracket x open bracket 2. Here we have f prime of 2 is equal to minus 1 minus 2 open bracket. In place of x, we write 2. You get it, right? So here we have minus 1. 2 times 2, we have minus 4. Here we have minus 1 minus 4, which is equal to minus 5. So the gradient m is equal to minus 5. Here we just discovered that we have gotten the point P, 2 comma minus 4, and then we have gotten also the gradient, which is m equal to minus 5. And then in the previous one, we talked about equation of a straight line. Equation of a straight line. We have different conditions based on the information or the available parameters given to you that we use to form the equation of a straight line. So when you have a point and a gradient, what is the formula you are going to use? So when you have a point and a gradient, you are going to say that the equation of that line is going to give you y minus y1 equal to m open bracket x minus x1. Is that true? Yes. So here now we have the gradient to be minus 5 and we have the point to be 2 comma minus 4. And then the formula we're going to use, we say y minus y1 is equal to m open bracket x minus x1. So this is the equation, or this is the formula to find the equation of a straight line whereby a gradient and a point is given. Okay, so but in this case now we are talking about the equation of a tangent. So because in this tangent, the gradient of the tangent is given to us, and then the point of tangent is given to us. So the equation that we're going to form is called the equation of the tangent. Okay, now let's go. Here we know our point P, 2 comma minus 4, and then we know our gradient minus 5. Let's fix it in. So we're going to have y minus open bracket. In place of y1 we have minus 4, we write minus 4 close bracket equal to, in place of m we have minus 5 open bracket x minus, in place of x1 we have 2 close the bracket. Okay, good. So we have y minus open bracket minus 4. When we open this bracket, we're going to have minus times minus 4. It's going to give us plus 4 equal to, we use this minus 5 to open the bracket. Minus 5 times x is going to give us minus 5x, and minus 5 times minus 2 is going to give us plus 10. So here we have y plus 4 is equal to minus 5x plus 10. let's take 4 to the other side. So it's going to give us y is equal to minus 5x plus 10 minus 4. When you see 10 minus 4 is equal to 6. So here we have y is equal to minus 5x plus 6. So we see that this is the equation of the tangent. Hello, this is the equation of the tangent. We have y is equal to minus 5x plus 6. Let's go further. Let's find the equation of the normal. Let's find the equation of the normal. But the question is, what is the equation of the normal? We say that the equation of the line perpendicular to the tangential line is the normal. Hello, that means we're going to find the equation of a line that is perpendicular to this equation of tangent that we've just found. Hello, we're going to form another equation that is what? Perpendicular to the equation of the tangent that we just formed. Now, when I say that two lines are perpendicular, what does it mean? Their gradient, we're going to say that m1, m2 is equal to what? Minus 1. When we say that two lines are parallel, we say that m1 is equal to m2. You get it right? We say that m1 is equal to m2. Now, here, we say that the equation of the normal is talking about the equation of the line that is perpendicular to the tangential line. We're going to find equation of a line that is perpendicular to the equation of tangent that we just solved. Okay, now what is the equation of the tangent? We have y is equal to minus 5x plus 6. And then what is the gradient of this equation? The m is equal to minus 5. The gradient is minus 5. And then we say that when two lines are perpendicular, we see that m1, m2 is equal to minus 1. So we have solved and we obtain m1 to be minus 5. That means we're going to say that minus 5m2 is equal to minus 1. Divide both sides by minus 5 because we want to find m2, the second gradient. So when we divide both sides by minus 5, we're going to say that m2 is equal to 1 all over 5. We're going to say minus 1 all over minus 5. So therefore, we're going to say that m2 is equal to 1 all over 5. Hello, we have gotten the gradient of the line that is perpendicular to this equation of the tangent that we just solved. We are still going to make use of the same point, but now the gradient is different. Hello, the gradient is different. Now let's go. Here we have the gradient of the normal and the point. So we have the gradient is 1 all over 5 and the point still remain the same, p of 2 comma minus 4. Okay, so the equation of the normal, well, let's apply the formula. We say y minus y1 is equal to m2 open bracket x minus x1. Okay, so we say y minus, in place of y1 we have minus 4 close the bracket equal to 1 all over 5 open bracket x minus x1 is 2, we have minus 2. So we say minus times minus 4 is going to give us plus 4. Here we have y plus 4 is equal to, let's use this 1 all over 5 to open the bracket. We're going to have 1 all over 5 times x, going to give us x all over 5. And 1 all over 5 times minus 2, going to give us minus 2 all over 5. Okay, so here we have y plus 4 is equal to x all over 5 minus 2 all over 5. This is in fraction form, right? Okay, now we want to remove this in fraction. We're going to multiply everything by 5. So when we multiply everything, we're going to have y times 5 plus 4 times 5 equal to x all over 5 times 5 minus 2 all over 5 times 5. Okay, so when we say y times 5, we're going to give us 5y plus 4 times 5 equal to 20 equal to x all over 5 times 5. We're going to see that 5 we cancel 5, then we'll have x remaining, and then when we say 2 all over 5 times 5, we're going to give us minus 10 all over 5, and minus 10 divided by 5 is going to give us minus 2. Okay, is that true? Yes. So here we see that 5y plus 20 is equal to x minus 2. Is that true? Let's take 20 to the other side. We're going to have 5y is equal to x minus 2 minus 20. Minus 2 minus 20 is equal to minus 22. So we have 5y is equal to x minus 22. This is called the equation of the normal. Hello. This is called the equation of the normal. Yes, we have stipulated the steps. The first thing you do, we are going to find the point of the tangent. The second thing we're going to do, we're going to find the gradient of the tangent, and then we'll say that the gradient of the tangent is f prime of x. Is what? F prime of x. Now let's go. After that, you solve for the equation of the tangent. After when you've gotten the equation of the tangent, for us to find the equation of the normal, we look for the gradient that is perpendicular to the line of the tangent. So when you've gotten the gradient, then you also use equation of a straight line slope form to find the equation of the normal. Is that clear? Yes. Let's take the second question. Number 2. Here we have y is equal to 1 all over 2 x squared plus 1 at x equal to minus 2. You get it? So the first thing we're going to do is to find the point. And then we know that the point is always written as p of x, comma y. And then we already know our x to be minus 2. Okay? So that means the next thing is to find y. Is that true? Yes. So for us to find the point, we're going to say f of x. F of x is going to give us the point, and f prime of x is going to give us the gradient. You get it right? F of x is going to give us the point, and f prime of x is going to give us the gradient. So here we say f of x. That means in the function that we have, let's plug in the value for x in the function. Okay, so that means we have y is equal to 1 over 2 x squared plus 1. In place of x, let's replace it with minus 2, which is the value of x. Okay, now let's go. We are going to have 1 over 2 open bracket minus 2 squared plus 1. So when you say minus 2 squared is equal to 4, 4 times 1 over 2 is 4 all over 2, and 4 all over 2 is equal to 2. 2 plus 1 is 3. So the point is going to give us, as we already know x to be minus 2, then y is going to give us 3. Then we're going to say that we have the point p open bracket minus 2 comma 3. This is the point of the tangent. Okay, now let's go further to find the gradient. Let's go further to find the what? The gradient. Now let's go. For us to find the gradient, we're going to find f prime of x. Now, f prime of x is talking about when we differentiate the function y. Okay, good. Let us differentiate 1 all over 2 x squared. That means we are going to have 1 all over 2 times 2x. That is, if you differentiate 1 all over 2x, we're going to have 1 all over 2 times 2x. When we differentiate 1, it's going to give us 0 because it is a constant. So 1 all over 2 times 2x is going to give us 2x all over 2. So 2, we cancel 2, then we have x. So f prime of x is equal to x. And then we see that x is equal to minus 2. We're going to find what? F prime of minus 2. So f prime of minus 2 is equal to minus 2. So we say that the gradient of the tangent is equal to minus 2. Okay, yes, let's use the slope form to find the equation of the tangent. Here we have gotten the point p of minus 2 comma 3 and the gradient minus 2. I think it will be very easy for us to go further, right? Yes. We are going to make use of the formula y minus y1 is equal to m open bracket x minus x1. Is that true? Yes. So here we say y minus our y1 is 3. We have minus 3 equal to our m is minus 2 open bracket x minus our x1 is minus 2. Then we have minus minus is going to give us plus. So we have x plus 2. Is that true? Yes. So here we have y minus 3 is equal to minus 2, open bracket, x plus 2. So let's use minus 2 to open the bracket. Minus 2 times x is going to give us minus 2x. Minus 2 times 2 is going to give us minus 4. So here we have y minus 3 is equal to minus 2x minus 4. Now let's take minus 3 to the other side. We are going to have y is equal to minus 2x minus 4 plus 3. Now, when you say minus 4 plus 3, it's going to give us minus 1. So, therefore, we have y is equal to minus 2x minus 1. And this is called the equation of the tangent. The equation of the tangent. The next thing remaining is for us to find the equation of the normal. And then we say that the equation of the normal is the equation of the line that is perpendicular to the tangential line. It is the equation of the line that is perpendicular to this equation of the tangent that we just gotten. Okay, yes, we have the equation of the tangent to be y is equal to minus 2x minus 1. And we have the gradient m1 is equal to minus 2. Is that true? And then we say that when two lines are perpendicular, that m1, m2 is equal to minus 1. And we have gotten m1 to be minus 2. So that means we're going to say minus 2 m2 is equal to minus 1. So we are looking for m2. So we divide both sides by minus 2. So when we divide both sides by minus 2, we're going to say that m2 is equal to 1 all over 2. Hello, we're going to say that m2 is equal to 1 all over 2. So here we have gotten another gradient that is perpendicular to the equation of the tangent. So we're going to use this gradient to find another equation. So that equation is the equation of a line that is perpendicular to the equation of the tangent. So this equation, new equation that is perpendicular to the equation of the tangent, is called the equation of the normal. Okay, now we make use of the point we already have, which is p of minus 2 comma 3. And then we make use of the new gradient we have, which is 1 all over 2. Okay, so the equation of the normal, using the slope form, we have y minus y1 is equal to m2 open bracket x minus x1. Here now we say y minus, in place of y1 we have 3, we say minus 3 equal to our m2 is 1 all over 2 open the bracket, x minus, we have x1 is minus 1, so we have minus minus plus 2. Okay, yes. Now here we have y minus 3 is equal to 1 all over 2 open bracket x plus 2. Let's use 1 all over 2 to open the bracket. 1 all over 2 times x is going to give us x all over 2. And 1 all over 2 times 2 is going to give us 1. Okay, yes, we know we have a fraction here. Let's multiply through by 2. Let's multiply everything by 2 so that the fraction will be removed. Okay, so we are going to have y times 2 minus 3 times 2 equal to x all over 2 times 2 plus 1 times 2. Is that true? Yes. Now when we say y times 2 is going to give us 2y minus, when you say 3 times 2 is going to give us 6. So here we have minus 6 equal to x all over 2 times 2 is going to give us x. Then we have plus 1 times 2 is equal to 2. So here we have 2y minus 6 is equal to x plus 2. Let's take minus 6 to the other side. We're going to have 2y is equal to x plus 2 plus 6. 2 plus 6 is equal to 8. So therefore we have 2y is equal to x plus 8. Here, this equation is called the equation of the normal. Yes, we have listed the ways to find the equation of the tangent and the equation of the normal. Please, I want you to use this same procedure, this method, to find number 3. The equation of the normal and the equation of the tangent. All right? Yes. Thank you very much for watching. Please like and share our videos and stay blessed.